Advanced Math Lesson 43 A and B have to do with periodic functions. And we're going to discuss first of all what a periodic function is. Periodic means to repeat. The period of the moon is every 28 days. It repeats that same cycle over and over. When we're repeating the same cycle, we're calling it in the shape of a sine, sinusoidal or sinusoid. And this is the prefix or the suffix, I'm sorry, oid means like something else. So like the sine function, graphs is how the moon goes around the earth, or how the earth goes around the sun. And if you think about even the shape that it passes through is sinusoidal in shape as we watch the sunlight hit the earth as the earth spins around. This sinusoidal shape graphs like this. It's periodic. It is a function because it does work. It's not a one-to-one function, but it is a function. And I look at it, and as I follow this along, it goes up and then back down, and it goes through the same sinusoidal shape, same period over and over and over as it goes through that same cycle, if you want to think of it that way. Now, the sinusoidal shape, and why it's called that is here. What we're going to look at next is when we're talking about the sinusoidal shape, how does it get this shape? So we're going to change our x value here, and we're going to, on the left is x, I believe your book leaves it as a theta, but we're going to call that x. So the x-axis is your run axis, and your rise is still your y. So nothing is changing there. The difference is if you just stick this in the graph on the calculator and you say y equals sine x or y equals sine theta, and you hit graph and you can't figure out why it doesn't show you anything on there. It just looks like a line, and you're like, that must be it. And that's because the way you're actually graphed in or zoomed into that graph. So we're going to change, instead of this being every one step as we go left and right, we move one up, and that would be the scales being the same, right? One left, one up would be the same scale. We're going to actually change this to being, this is 30 units to your right, and 45 units, and 60 units to your right, and we're going to call this a degree line instead. Okay? Once we do that, we start plugging these in, and so in other words, notice that this is only a 0.5, this is a 1 up, and then a 1 down. That scale of 1 up is definitely not, 1 here is not 1 here. Notice that this is, 1 this way, it's about 135 that way. So the scale is not correct at all, but this allows us to visualize it much easier. So when we look at this, we've changed these into degrees, and we say we're going to go between 0 and 180 for this portion. So I put in a line 0 to 180, and then I started putting them in. Well, what is the sine of 0? Sine of 0 is 0, sine of 30, 0.5. And I filled this chart out. Now notice what this chart is doing. 0, 0.5, 0.707, 0.8866, 1, 0.866, 0.707, 0.5, and 0. And if you notice, if I graph those, it goes up and it comes back down. Now, if we were to continue this, and I didn't because of the board, and I did this with the cosine function, you'll see in a moment, but this function would go up to 1, and then down to 1, and then up to 1, and down to 1. So in other words, if this, as this number gets bigger, it continually repeats itself up and down. This function that does so, there you go, this is this little piece, that's all you're looking at is from here to here. That's from 0 to 180 degrees. That's from 0 to 360 degrees. From 0 to 360 degrees, it goes through one complete cycle, all the way to its maximum, to its minimum, and back to where it started again. This would be the next 360 degrees. And it would continue on because I have an infinite number of degrees that I could go, or negative degrees that I could go, and it would continue to graph this same function over and over and over. That's why it's called periodic. Now, that's the sine. Let's look at the cosine. The cosine is very similar to this. It is still considered to be called sinusoidal. And I know that sounds confusing. How can the cosine be sinusoidal? It's because the shape is that of the sine. The sine is our first function we look at. So it still has that same idea. The difference is that when I start plugging in my same values, and I went ahead and did 0, 45, 90. So I'm not being as precise on these. I'm going from 0 to 45. I'm skipping the 30 to 60 to 120 so that I have enough room on my little table here to go from 0 all the way to 360. Of course, if you remember, 0 and 360 is the same thing. It's gone all the way around, right? A 360-degree turn means that you end up where you began. So when I start plotting these points, it goes 1, 0.707, 0, and sine, remember cosine of 90 is 0, and then negative 0.707, negative 1, 707, 0, 0.707, 1. So what do we, when we graph this, notice that the sine function when we put in a 0 was at 0. It went up like this and then came back down, right? This one is shifted over, here it is, and it's starting at 1, still going down to negative 1, and then back up to 1. So the sine and the cosine function are what's called phase shifted off of each other. And we'll get into how to phase shift at a later lesson. But for right now, we understand that these numbers, or these graphs are very similar, with just there being the cosine of 0 is 1 and the cosine or the sine of 0 is 0. So they're starting at different points, and then they're accomplishing the same graph or same shape over and over again. Now let's go ahead and look at something else here that we could change, and that is, what if I had a number out front of one of these? I went ahead and graphed y equals 2 sine theta, and what it does is it makes this sine go from negative 1, all the way to 2, negative 2. It shifts it upward like that. It stretches it. The word that we're going to use for that is the amplitude. Okay, and I know this isn't a science class, but if you remember that AM radio is amplitude modulation. What they're doing is they're changing the amplitude of the carrier signal. So this is how much difference in amplitude there is. Keep in mind also, this is not physics, but my voice, I can talk louder or I can talk quieter, and as I do those things, I may not be changing the tone of my voice or the pitch, if you will. It's not changing the frequency, but it is changing the loudness, which is directly related to the amplitude, or how high and how low that is. And so this amplitude, this means it's going to be twice the amplitude of the normal sine function. So if instead of going from negative 1 to positive 1, it goes from positive 2 to negative 2, or back and forth. And the best way to think of that was it's doubling the function. Okay? In the same way I can do the cosine function. A 3 cosine of theta is going to do the same cosine function. Right? It's still going to get to these maximums and minimums at the same points. The difference is that maximum and minimum are going to be between 3 and negative 3. Now, the way that you kind of think of that in your head is it's the maximum displacement from its center line. And I'm being very careful not to say from the axis, because this graph could be shifted up or down, and we'll get to that later on these. But for right now, I have to remember it's from the center line. Some books will explain it. Instead of saying from the center line, they'll say the maximum minus the minimum, right? That would be the total amount, divided by 2. The absolute value of that is going to be the amplitude. You can think of it however you'd like, but that's the amplitude, is how much I'm stretching that. Well, could I squish it? Sure. 1/2, that would be half the amplitude. It will only go up and down to negative 1/2. What about the negative out front that I threw on this one? And that negative out front, that's going to make it a little more unique. See, it's going to take this sine function and flip it over. So instead of going up and then down like it normally would, so the normal 0.5 or 1/2 sine would go up and then back down, it's going to take that and mirror it and flip it back over, because every value I put in becomes a negative. And so it will flip it over as such. I did one other thing here, and the book did mention this. Remember that pi equals 180, and 180 equals pi. So I can always convert these back and forth. And sometimes you're going to see these in the book and in real life, where you have a function that's graphed, the sinusoid function, but instead of labeling these with 90, 180, 270, and 360, it's just pi over 2 pi, 3 pi over 2, 2 pi, and so on. And that works just by exchanging 180 for pi. That's really how you're going to do that. So don't let that bother you as far as that goes. Now, this lesson is going to have quite a few where you're identifying these graphs. So you're going to look at the graph and say, oh, it crosses the vertical axis at 1, or it crosses the vertical axis and goes downward from there or upward from there, and I'm going to have to go ahead and define that trig function from it. So you should be able to look at this and recognize, oh, this is a cosine function, and this is a sine function. And then what's the amplitude? Of course, this is twice as much. If this was a 6 here, and it went up from 0 to 6 and down to -6, this would be a 6 here. But once again, it's that center line. So even if we had one like that, and we said, well, what about this one here? I could still have the same sine function going up and down. If this was at 5 and 6 and 4, this still would have an amplitude of the same 1, because it's only going between 1 down and 1 above the center line. And we'll get to how we can shift that up and down later on, and shift it left and right with a phase shift in another lesson. But just so that you're understanding that we can very easily identify back and forth sine and cosine functions from their graph and from their equation with graphing them.